All right. Hey, what do you call a plane that doesn't fly directly to where it's going? A complex plane. All right. So we are going to dive into the real and imaginary axis. Okay. So we're gonna have like real are things in real life, and then my friends are on this axis because my friends are imaginary. All right. So the good news is, have y'all ever graphed in the imaginary axis? Have you guys ever had an imagination? Let's graph them. Watch this. It's gonna be mind blowing. What part of this is real? 3 is real, and this is imaginary. So, if this is my real axis, the 3 tells me to go right 3. And what's that 4 tell me to do? Up 4. So, because this is my I, and this is my real. So now this looks really complex, doesn't it? Because it technically is, but is it? Not really. So don't overthink these. Dealing in the imaginary plane is not as bad as what you think it is. So like for B, how far to the right am I going to go? None. How far up? To I, right? Because technically all these are I's. And they have not looked at the eclipse, so they all work well. You mean today?
Oh, so when I wake up tomorrow, there should be 2 big black spots.
All right. For C, what am I going to do? Left 2, up 3I. You guys catch the drift there? D, -4, 0. F is -1, -2. And gee whiz, 3, -1. I don't know. That feels okay. Let's just end it here. Why is there no E? There's enough on your report card. For excellent job. S and S pluses. All right. This is where things are going to get a little bit more wild. So, A plus BI, we are looking at as a point now, right? Now, A plus BI, the modulus, the absolute value of this, is equal to this. Where have we seen that before? What have we called it before? What have we called this formula before? Have we ever used it to find the hypotenuse? Have we ever used it to find distance? And have we ever used it to find, well, this might be a new one. Yeah, hypotenuse. 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 Hip up, anonymous. All right. So this formula is coming up again. It works in a complex thing too. What we're going to do is sometimes you do this, you get a negative, and that's going to give you part of the complex. Boop. Can I make that into a right triangle? Now what I'm going to do is, what did we also call up here? Absolute value is Z, right? Z. Z. If you do a lot of math, they start calling it Z. So absolute value is Z. This is also your magnitude. It's your hypotenuse. It's your distance from 0. So can I label over here as that? Just so you guys also know, this double bar thing means magnitude. Now again, this all looks scary, but is it things we've seen before? Yes, we're just introducing you to new terminology. I don't think you'll see a lot with it because that's vector stuff, which we'll get into eventually. So you know it's not 2. Because a Z, if you write it crazy, can kind of look like a 2. Like some people write 2s like that. So I do it just so you guys know what Z. It's a Z answer. Now, if this is A plus BI, which side of these am I going to label as A? Bottom, because that's my real number, and that's my complex. B, because it's on the imaginary plane. So we know that there's an I associated with it. Now think about this. Which one is cosine going to be associated with when we get to it? Is it going to be associated with A or B? A, because cosine's your x, and B is going to be your sine. So again, we're doing everything we've done before. We're just introducing new terminology. Because is this the same to what we've done? Is how I find the angle? Yeah. So these are the same to what we've done. Oh, and don't forget we have to add pi if we're not in the right quadrant, right? You need to add pi if you're not in the right. If you're not where you're supposed to be, you gotta add pi to it, and that'll get you where you need to be. Sound good? This is gonna look really crazy, but I assure you it's not too bad. Only my hopes. Alright. Do you guys want to see a proof why it works to add pi, or are you guys good? Okay. Alright. So now let's do this. Look at this. Imagine this problem. It looks scary, right? What if I told you I would graph it first? I'm going to graph it first. If I graph this, I go over 5, right? And I go up 12. I put a point there, right? Y'all agree with what I just did? Now, let's just do it. So what's this absolute value of z? How do I do that? I'm going to do a squared plus b squared, right? What's my a and my b? -5 and 12. And that equals 13. So my magnitude of z is 13. The hypotenuse is 13. Did I do that right? I did. Any questions how I did that? It's Pythagorean theorem, right? Distance, magnitude formula. No, because it's a length. The length of it. Magnitude is always going to be a real number because it's a length. And lengths cannot be imaginary. So now I need to find this angle right here, right? Because we always start at 0. Now when I do, this is not on the unit circle, correct? When I go set this up, I'm going to do tan of theta equals my b over a, right? Now my question is this. Is my calculator going to give me this answer? Nope. It's going to give me the wrong answer. It's actually going to give me this answer. It's going to give me the one that's right below it. But how do I flip to the other side? You're going to add pi. So I'm going to grab my calculator. I'm going to do tan inverse of 12 over -5. Or -12 doesn't matter. I'm going to see what I get for that. I'm going to get -67.38. Again, we're in the wrong quadrant though. So how do I get to the right quadrant? I add pi to it, right? So remember, anytime you're here or here, you got to add pi to it. Adding pi to anything makes life better. So instead of pi, what can I add to it? 180, right? And what's 180 plus negative 67.38? 112.62. Oh. Now, if I would have done this in radians, which I should have probably did it tell us what to do? If you did it in radians, you would have gotten negative 1.176. And then I would have added 2 pi to that and gotten 1.966. Both are the same thing. Which answer is going to be better? Radians is better. I actually just read through a test section that said make sure all your answers are in radians. Now, if they don't tell you, are both acceptable? Yes. Okay. Any questions on this? Okay. Where'd that thing go I dropped? Holy smokes. Well, if during the eclipse pre-calc fails to work, and everything I taught you was wrong. Side note, do you guys want to take the test? We already talked about it. You guys testing in here, right?
Yeah.
Okay. Let's graph this beast. This one's going to be even easier, y'all. Do you believe me?
No.
All right. Z is negative 7i. How far do I go left or right? None. I go down 7. All right. What's my length of Z? 7. Because it's a straight line, right? And what's my theta going to be? So remember, I start here and I go around, right? So what's that theta? 270 or, oops. Now, what if they ask you to show work?
Yeah, buddy.
By inspection. I looked at the graph. Because there's no work to show, right? Can I do Pythagorean theorem on it? Yeah, it'd be square root of 7 squared plus 0 squared, which is 7. Can I draw a right triangle in there? No, you can't have a triangle with side 0. All right. How'd that one feel? Good. All right, now let's get to the nitty gritty. Why did we come here? What's the point of all this? Because I want to convert this to polar form. I'll give you the proof. So let's draw this in. Let's draw on our triangle. This is A, this is B, this is Z, right? Or actually, let's do this. I don't want to call it Z right now. I'm going to call it R. R for radius. Now R, remember that this equals this, right? They're just different forms. They're going to be the same thing. So if I'm looking at this triangle, I'm going to show you a proof now. Cosine of theta equals A over H, right? So that's A over R. Agreed? So how do I get A by itself? There you go. That's the proof for why that is. Have we seen that before? Yeah, we have. Same with this one is B over R, right? So how do I get B by itself? There you go. That's the proof. That's a mathematical proof. We're just showing it to you in a different form. So, but I want you to write it in this complex form. So to do my complex, how do I get my a coordinate? Now remember, my a is also like my x, right? So I'm going to write it as z equals, what's my a equal to now? R cosine of theta plus what's my b? R sine of theta times I. Ooh, eep, 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 eep. Don't do that. Yeah. Don't put that at the end. We're going to put it in the front. Because at the end, sometimes people want to plug it in. So we are converting polar to complex now. Who's ever going to use this? There's only one career field ever that has any sort of complex numbers in it, if you want me to be honest. Electrical engineers. They have to deal with complex numbers with currents and such. For some reason, like electricals, you can get negative square roots. Mechanical engineering, you'll never see it. Chemical engineering, never see it. Like, no, square root of a negative number. It happens in resistance charges and stuff. It's part of the calculation. It just occurs. Because remember, it can go both directions, so you have to include it in it. It's actually really interesting. Okay, it's not interesting. It's amazing. At least that's why I'm still in college. All right, so that vis-a-vis, that gives us this beast. It tells me that this. Can I pull an R out of both those? Z equals R times cosine plus I times sine. Okay? It looks really complex because it is complex, but it's not that complex. Okay? It's less complex than most of y'all's relationships. I'm joking. I'm calling them. There's a massive applause. All right. So let's do this. Now let's work backwards. I have that. I want it in polar form. What's polar form mean? I have R theta, right? I need an R and I need an angle. So I graph it, draw a triangle. I need to find an R and a theta. Now luckily, all this stuff is just triangle stuff, right? How far to the right did I go? Square root 3. How far up did I go? 1. Is this on the unit circle? Yeah. Because if both these are over 2, what angle is that? That gives us root 3 over 2 to the right and a half up. Pi over 6. Whenever you see that root 3 and a 1, just remember that it's always proportional, right? If you didn't see that, when you go and divide them, when you go and find your ratio, it's going to work too. I was just showing you guys a shortcut. What was my A on this one? Root 3. My B is 1, right? How did I find my radius? Yeah, square root of 3 squared plus 1 squared. And that is 2. Every day. Now let's say I didn't know that trick I just did. I could have set this up like this. I could have done tan of theta equals what? Opposite 1 over root 3. And then again, I can go to my unit circle. And where would I have a 1? Oh, I erased it, but 1 over root 3 when I divide them. It was pi over 6. I hope the picture of me acting ridiculous ends up in the yearbook. Like, what class is that over there? Everyone needs to just... Stone's out. Oh, he's gonna be in here tomorrow, snapping pics. Yeah. Oh, that'd be fun. Let's do a soft lockdown during the SAT again. All right. That happened once. All right. I'm gonna go over square root of 6 and down square root of 2. Do you guys agree on that? X and Y. Square root of 6. Negative square root of 2. Y'all agree or disagree? I told you, this stuff, like, I don't know, everyone kind of seems out of it still. But how do you guys feel about this so far? Like, how's it look? Not good. You just make sure you know that this is your X, that's your Y, and draw a triangle. And then okay. All right. So A, how do I find A? That's the first part. How do I find B? It's, negative root 2, right? That's a negative in front. How do I find R? It's square root of square root of 6 squared plus, technically it's negative root 2, but it's always going to be positive. And that's what, square root of 8? Yeah, it's square root of 8. Can I leave it as a decimal? Yeah, I'm going to. Could I, for some of you who are sticklers, could I make that 2 root 2? Is there any benefit? Oh, there is a huge benefit to that, actually. So I'm going to. Do you guys know how I did that? You guys remember this? Oh, I skipped a step. But there is going to be a benefit to that on this piece. Kinda. So when I go to find theta, I'm going to do tan inverse of my y over x, right? With square roots, if you have like square root of 5 over square root of 10, can I simplify that? You can. They're wearing the same hat. You can divide, multiply. So can I simplify that? So that's 1 over 3, right? Wait a second. What's square root of 1? No way. Negative 1 over root 3. Now, will my tan inverse give me... Well, I'm going to use the unit circle. But if I was using a calculator, would my tan inverse give me the right angle? Yeah, because it does in 1 and 4. So I'm going to come over here, and where would I have a 1 over root 3? If it's y over x. That'd be root 3 over 1. That'd be 1. So it's 11 pi over 6. How am I doing that so quick? If everything's over 2, do I have to worry about the 2's when I'm dividing them? No. So I just ignore it. Like my kids do to me. Am I doing 14? No, we're going to skip that, actually. I hope it doesn't bite us in the buttocks, but I think we'll be... Well, can I show you guys 14 really quick? It's not bad. Wait, do we have time? Oh, we got time. Watch this. This is going to blow your guys' socks off. That's an old expression. Watch this. Change from polar to rectangular. What's cosine of 3 pi over 4? Yeah. Negative root 2 over 2. I'm just looking ahead. What's sine of 3 pi over 4? I'll put a minus here. Do you guys see what I did? Oh, that was... I'm sorry. I wasn't thinking. Everyone see what I did? I just plugged them in. Unit circle. What do I do with the 5? Nah, you could have done 5i, or it doesn't matter. There you go. We did it. That's it. We plug it in. We just go through and we plug in the pieces. Because it was polar. That's polar with cosine sine. Without cosine, sine is rectangular for a complex. Doesn't that make you... So how would I do this one? Guess what I do? I just look at the unit circle, right? What's cosine of 4 pi over 3? Why am I looking at this? Negative a half. And then it'd be plus 4 pi over 3 is what? Positive root 3 over 2? Oh, why am I struggling today? And then what do I do with my 3? That's it. Do you know what I mean? That's it. Don't overthink that. Like, I'd hate for you guys to get that one wrong. Yeah.
Why are you not adding them together if it's
Because they have an I. They have to be in the form A plus, you know, that has an I, that has an I. Does that make sense? So, no, they want to be set. You want to keep them separate. You want to keep them separated. Hey. All right. There you go. That's it. That's record time, y'all. 26